Okay, so let's start um, exam number 5 review. So problem 1, complete the table for the given function. Okay, so let's try to plug in these values. So f at -3 is 2 to the -3, which is 1 over 2 cubed, which is 1 over 8. F to the -2, 2 to the -2, 1 over 2 squared, 1 over 4, 2 to the -1, 1 over 2, 2 to the 0, 1, 2 to the 1, 2, 2 squared, 4, so let's do 3, I guess, 2 cubed, 8. Okay, so let's do this. And so 1 over 8, 1 over 4, 1 over 2, 1, 2, 4, 6, 7, 8. Okay, so it should look something like, so we get close to close enough. Okay, so 1. Okay, so that is what the graph looks like. Rewrite. And so the base is e, exponent is b, the result is e to the -2. Oh, let me just see. It just says complete and draw that. Okay, so write is a logarithm. And so the base is 2, result is 1 over 32, and the exponent is -5. And that is your answer. Complete the table. And so let's write this as y equals log base 2 of x minus 1. So that means that the base is 2, exponent is y, result is x minus 1. Let me add 1 to both sides of my equation. And so that says that x, oops, so it says here that x is equal to 1 plus 2 to the y. Okay, so let's make this just slightly smaller. Okay, so let's evaluate when y is -3. So I have x is equal to 1 plus 2 to the -3, 1 plus 1 over 2 cubed, 1 plus 1 over 8 is 9 over 8. I have a little bit of room issues here. 1 plus 2 to the negative 2. 1 plus 1 over 4 is 5 over 4. 1 plus 1 half, 3 over 2. 1 plus 1, 2. Let me go up here so I have at least some room. 1 plus 2, 3. 1 plus 4, 5. 1 plus 8, 9. Okay. Let me do the next problem. Evaluate. And so I can rewrite this by the change of base formula. And so I can write this as, or let's say, let's do this base 10. So this is the log of 5 over the log of 2, which is approximately, I'm going to have trouble with this, putting it into, so log of 5 divided by log of 2, you can just plug this into your calculator. And so you get approximately, oh, maybe I'll move this over slightly so I have some room. I have to move these over. Okay, so I'll at least have some room here. 2.321928.095, etc. Okay, so let's do problem number 6. Rewrite each expression as a single logarithm using properties of logarithms. So this is equal to ln of, well, let's raise the, so the x is the numerator, and let's raise the x up to the exponent, the number out in front, 3. I have a plus, so I'm going to multiply, and I'm going to raise the y up to the exponent out in front, 2, and that is your answer. Let's do the next problem. And so I have the base is 5. I can rewrite 1 over 25 is 5 squared is 25, so 1 over 25 is 5 to the negative 2. Since the exponential function is 1 to 1, and since the bases are equal, the exponents must be equal. And so, subtracting 4 from both sides, x is negative 6. Let me do problem number 8. And so, I'll do the same thing. Base is 5. I can rewrite 125 as 5 cubed. Therefore, since the exponential function is 1 to 1, and the bases are the same, then the exponents must be equal. So x is equal to 3. Well, in this case, I can't really do anything. I can't find a common base. So I'll have to take the log of both sides. I'll use the natural log. And so let's bring the x squared out in front. So x squared is equal x squared ln 5 is equal to ln 14. Divide both sides of my equation by ln 5. And so I have x squared equals ln 14 over ln 5. Therefore, by the square root property, x is plus or minus the square root ln 14 over ln 5. And actually, both of those work if you plug in. And so that's your answer. Do the same thing. Let's take ln of both sides of my equation. And so I get, let's bring down the x plus 4 out in front of the logarithm. So x plus 4 ln 4 is equal to ln 11. Let's multiply the ln 4 inside the parentheses. So x ln 4 plus 4 ln 4 equals ln 11. Subtract ln 4 from both sides of my equation. 4 ln 4 from both sides of my equation. So x ln 4 is equal to ln 11 minus 4 ln 4. And so, dividing both sides of my equation by ln 4, I have x equals ln 11 minus 4 ln 4 divided by ln 4. And that is your answer. So let me actually make this a little bigger then. Let's see if I can, okay, if I can draw this ln 4. Okay, there. Oops. Okay. Okay, so let me do the next problem. No, let's make this a little smaller for 1 second. So you can get some room. Okay, so solve for x. So I have here that let's go to 120. So I have here that the base is 2, exponent is x, result is 128. I can rewrite 128 as 2 to the power, I think, 8. 2, 4, 2, 4, 8, 16, 32, 64, 128, 7. And so I have that since the exponential function is 1 to 1, and since the bases are the same, then the exponents must be equal. So I must have that x is equal to 7. Okay. Let me do problem number 12. And so subtract 3 from both sides, 2 from both sides. So I have that 6 log base 4 of 4x plus 5 is 3. Divide both sides of my equation by 6. So I have that log base 4 of 4x plus 5 is 1/2. And so the base is 4, exponent is 1/2, result is 4x plus 5. The square root of 4 is 2. Subtract 5 from both sides of your equation. And so 4x is equal to negative 3. Divide by 4. So x is equal to negative 3 over 4. When x is equal to negative 3 over 4, 4x plus 5 would be a positive 2. So I'm taking the log of a positive number, so I can do that. So this is your solution. It's not extraneous. Okay, let me do the next problem, problem number 13. So, by the properties of logarithms, if I'm adding two logs, that's the same as taking the log of their product. So let's multiply x here times x plus 2. So x times x is x squared. X times 2 is 2x. Let's rewrite this as a exponential form. So the base is 2, exponent is 3. Result is x squared plus 2x. 2 cubed is 8. Subtract 8 from both sides. And so I have that x squared plus 2x minus 8 is 0. Let me factor. Okay. And so I have here x plus 4, x minus 2 is 0. And so setting these factors 0, I have x is so x plus 4 equals 0, or x minus 2 equals 0. So x is equal to negative 4, or x is equal to positive 2. If x were equal to negative 4, then I'd be taking the log of a negative number, so I can't do that. So that's extraneous. I can take the log of 2. 2 plus 2 is 4. I can take the log of 4. And so that is not extraneous. Okay, so now let's evaluate this. Well, by the change of base formula, the log base 5 of 8 times the log base 8 of 25, well, this will just contract and become log base 5 of 25. The exponent of 5 that yields 25 is 2. And that's your answer. Let me do the next problem, problem number 15. And so I can use any base I want. I used the common log last time for the change of base formula. So let's use the natural log, I guess. And so this is ln7 over ln3. Now it doesn't make any difference which of the bases I use. But, so since I used one last time, I'll use the other one this time. And so ln7 over ln3 is approximately 1.77 1243,749. And that's your answer. Okay. If $6,000 is invested in an account with an annual interest rate of 7.5% compounded continuously, how long will it take for the amount to double? Okay, so let's do that. So we have here initial investment of $6,000. We want to determine the amount of time, until the amount doubles to $12,000. Given that the interest rate is 7.5% compounded continuously, and so we use the following formula. And so I have 12,000 equals 6,000 e to the r t. So a equals p e to the rt. Divide both sides of my equation by 6,000. And so I have 2 equals e to the 0.07 t. Take ln of both sides of my equation. And so you get 0.075 t equals ln 2. Divide both sides of your equation by 0.075. And so I have that t is equal to ln 2 over 0.075, which is approximately. And so let's plug that into our calculator. So it's ln 2 divided by 0.075 is 9.24196 2407 years. And that's your answer. So approximately, so years. Let's keep looks even worse. So let's see if I can put years in here. It's very hard to. Okay, good enough. So t is approximately 9 years. 9.24 years. About 9 1/4 years. Okay. Approximately 9 years and 3 months, I guess. I'll say that. An account which deposits $7,000 have been accumulating interest at 5% continuously compounded for 18 years. Find the initial deposit. Okay. Maybe I'll start up here. I'll just write the. So amount contained $7,000. So after 18 years, we have $7,000, and the interest is 5%, and we want to figure out the initial deposit, where we're using the continuously compounded interest formula. And so let's do that. And so I have that, well, A is 7,000. Don't know P. R is 0.05. And T is 18. And so 0.05 times 18, 0.9. Divide both sides of your equation by 0.9. And so P is equal to 7,000 divided by e to the 0.9, same as e to the negative 0.9. And so this is approximately, well, let's see. So 7,000 e to the negative 0.9 is 2845.987 618, etc. And so this is approximately, since we are talking about dollars, we're around to the nearest penny, $2,845.99. So that's our initial deposit. Okay. Find the equation of circle with points as endpoints of a diameter. So let's recall the midpoint formula found by just finding the average of the x and y coordinates. And so the center is negative 5 plus 7 over 2, 2 plus 8 over 2. And so the center is at the point 2 divided by 2, 10 divided by 2, and so the center is at 1, 5. Okay, so therefore, there. Okay, therefore, um, the equation of my circle with center HK is as follows. And so in this case, uh, I guess I'll use 7, 8. So x is 7, h is 1, y is 8, k is 5. And so I get 6 squared plus 3 squared is r squared. So 36 plus 9 is r squared. So r squared is 45. And so the equation is just x minus h squared plus y minus k squared equals r squared. And that is the equation of my circle. Okay, sketch the graph. Oh, so I don't need that much for this one. I should have. So the center is at the origin. R is 4. So it's just seeing if I can actually do this. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay, so let's try that. I think I'm going to make it smaller. Maybe that will help. Okay, so let's see if smaller helps. Okay, let's try. Close enough. Okay. It's a little. Let's just say forget this, and I'll just. So here's some. Uh, the center is at the origin, and it looks something like this. The radius is 4. And well, it's supposed to be a circle. Okay, well, again, it's problems with this tablet. It's a little hard to draw. Do it a few times. On average, it comes out not too bad. So if I draw it, go around a circle about 5 or 6 times, then on average, all the wiggles aren't too bad. So they sort of even out. Okay, so identify the vertex. Okay, so let's do this. And so, and plot 5 points. So the vertex, so this is y equals x squared plus 3. Subtract 3 from both sides. So the vertex is at 0, 3. And so let's plug some points in. -2, -1, 0, 1, 2. And so -2 squared plus 3. 4 plus 3 is 7. -1 squared. 1 plus 3 is 4. 0 squared plus 3. 0 plus 3 is 3. Maybe I'll plug here. 1 squared plus 2 is 3. Plus 3 is 4. 4 plus 3 is 7. Okay, so let's try to draw this. Okay, so 0, it's 3, 4, 3, 4. Ha! Even trying to do that is hard. 4, 7. Close enough. Okay, good. So let's try to draw this. Okay. Close enough. Okay. No, close enough. Okay. Okay, so there. So the vertex is at 0, 3. Okay, so that's what it more or less looks like. Find the coordinates of the vertex and axis symmetry. So for the axis symmetry, x equal negative b over 2a. So negative 8 over 2 times 2, negative 8 over 4, negative 2. And so the axis of symmetry is x equal negative 2. Let's try to find the vertex. And so I know that the vertex is going to be at negative 2, and let's figure out the corresponding y-coordinate. And so f at negative 2 is equal to, let's plug in for x negative 2, 2 times negative 2 squared plus 8 times negative 2. Huh. Okay. Darn. 8 times negative 2 plus minus 4 is equal to 2 times 4 is 8 minus 16 minus 4 is equal to a negative 12. So my vertex is at 2, negative 12. Okay. Find the zeros of your function. And so to find the zeros, oh, it can either be with or without an e. So the zeros are going to be, well, x squared minus 3x plus 2 equals 0. And so I can factor that as x minus 2, x minus 1 is 0. And so x minus 2 is 0, or x minus 1 is 0. Add 2, 1 to both sides of the equation. So x equals 2, x equals 1. And those are the zeros of my function. Find the zeros. And so to find the zeros, I have x squared plus 8x minus 1 is 0. So I'll use the quadratic formula. Oh, that's pretty good. And so I have x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to, okay, darn, x is equal to negative 8 plus or minus the square root of 64 plus 4 over 2, negative 8 plus or minus the square root of 68 over 2. So I can write 68 as 4 times 17. So I can write this as a negative 8 plus or minus 2 rad 17 over 2. I can factor out a 2 from the numerator. I can cancel the 2's. And so I get that x is equal to -4 plus or minus rad 17. And those are your zeros. Okay. Find the vertex and intercepts. Okay, so let's do that. So let's find the vertex. So let's first look for the axis of symmetry. And so I have here that x is equal to negative b over 2a. So negative, darn, b over 2a. So negative 2. So the axis of symmetry is x equals negative 2. So let's find the vertex. Well, the x-coordinate of my vertex is negative 2. Let's figure out the corresponding y-coordinate by plugging in for x. Negative 2. And so this is equal to 4 minus 8 plus 4, which is 0, which means that's actually going to be one of the intercepts. And so I have here, let's find the x-intercepts. In this case, x-intercept. So that's x squared plus 4x plus 4 equals 0. Factor, well, this factor is that x plus 2 squared is 0. And so x plus 2 is 0. Subtract 2 from both sides of your equation. So x equals negative 2. Therefore, the x-intercept is at negative 2, 0, which we already found. And let's do the y-intercept. So let's plug in for x0 and solve for y. And so I get 4. So the y-intercept is at 0, 4. And so I found the vertex and the intercepts. Okay, so let's sketch the graph of this. In this case, this is going to be an ellipse. Because, well, I know that I have 2 square terms, and they're both of the same sign. And so because of that, then I know that it's going to be an ellipse. So the first thing to do is to put into the standard form for ellipse. So let's divide both sides of my equation by 2,304. So if I do that, then I get x squared over 36 plus y squared over 64 is 1. And so in this case, A is 6, B is 8, 64 minus 36. And so you remember to change the sign, so it will just be 64 minus 36 is 28. And so C is the square root of 28, which can be written as, well, 4 times 7 is 28, square root of 4 is 2. Okay, so therefore the center is at the origin. The vertices are at, well, plus or minus 6, 0. and 0 plus or minus 8. And the foci, since 64 is bigger than 36, will be along the y, so 0 plus or minus 2 rad 7. Okay, and that's about it. Okay, so let's do that. Maybe I'll make it a little bit bigger. Okay, so 0, 6, 8. So 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 8. 1, 2, 3, 4, 5, 6. 8. And then square root of 28. That's a little bit bigger than 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now let me make it smaller, see if it will help me to sketch a graph of this. Who knows? Okay, so let's see if I can do this. So I'm going to have to try to connect these dots. Okay, let's try as best I can. Okay, it's a little squiggly, but good enough. So here's a vertex, vertex, foci, center, foci, foci, vertex, vertex. Okay, good enough. That's good enough. Okay, so let's do problem 26. Let's try to complete the square. So let's write this as, and I guess maybe I'll give more room to do this. So I have here a 16x squared minus 64x plus 25 y squared. So this is going to be an ellipse because the signs are the same. So again, it'll be some sort of an ellipse. Minus 50y equals 311. And so I have 16x squared minus 4x plus 25 y squared minus 2y was 311. Negative 4 divided, since there's a 1 in front of the y squared, negative 4 divided by 2 is a negative 2 squared is 4 times 16 is 64. Negative, again, since there's 1 in front of the y squared, negative 2 divided by 2 is a negative 1 squared is 1 times 25 is 25. Okay, good. So I have 16 x minus 2 squared plus 25 y minus 1 squared equals 400. Let me just check. Divide both sides of my equation by 400. And so I get x minus 2 squared over 25 plus y minus 1 squared over 16 equals 1. So actually that's a pretty nice equation. So I have here that A is 5, B is 4, 25 minus 16 is 9, square root of 9 is 3. And so the center is at the point 2, 1. the vertex found by adding and subtracting 5. 2 minus 5 is a negative 3. 2 plus 5 is 7. Adding and subtracting 4. 1 minus 4, negative 3. 1 plus 4, 5. Adding and subtracting 3 to, well, 25 is bigger than 16, so it's going to be to the x. So 2 minus 3 is a negative 1. 2 plus 3 is 5. Okay, and so let's do this. Let's make it a little bit bigger so I can try to plug these in. Okay, so the center is at 2, 1. So that's the center. So I go over 5, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I go 4. 1, 2, 3, 4. 1, 2, 3, 4. And I go 3. 1, 2, 3. 1, 2, 3. Okay, well, see if I can do it at this zoomed out level. Not bad. I'm going to keep, this is a keeper. Actually, in this case, it looked even better. So the center, foci, vertices. And I'm done. Find the equation of ellipse. So first off, the midpoint of the foci is the origin. Therefore, the equation of my ellipse is as follows, where the foci are at 12 and minus 12. Therefore, C is 12. The length of the minor axis. So the focal axis is in the x direction. Therefore, the minor axis is in the y direction. So that's going to involve B. I have a length of the minor axis is a length of 32. So this, say this. So this is the minor axis here. Of course, yeah, okay, good. So the minor axis in the same direction. So the minor axis is a length of 32. So half of it is going to be 16. Since the center is at the origin, that means that B is 16. A squared, well, and so I have here that A squared minus B squared is equal to C squared. And so A squared is equal to B squared plus C squared equals 16 squared plus 12 squared. So A squared is equal to, give a little bit more room here. So 16 squared, which is 256, and 12 squared, which is 144, which gives you 400. So the square root of 400 is 20. So in this case, A is 20. So maybe I'll put that back here. And so therefore, the equation of my ellipse is x squared over 20 squared plus y squared over b squared equals 1. And that is the equation of my ellipse. Okay. Sketch the graph of this hyperbola. Okay. So in this case, the center, well, A equals 3, B equals 5. 25 plus 9 is 34. So C equals 34. The center of this hyperbola is at the origin. The focal axis will be along the y-axis, since there's a plus in front of the y. The real axis will be along the y-axis, the focal axis. So the vertices are at 0 plus or minus 5. The focus will be at 0 plus or minus rad 34. The asymptote will be at y equal plus or minus b over a. And that's it. Okay, so let's try to draw this. Okay, so let's see if I can draw this hyperbola. And so 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so let me try to draw the bounding rectangle. Let's see if I can do that at least. Okay, let's see if I can. Okay. Okay, good enough. Okay, let's see if I can. Oh, maybe I'll do it in this color. So let me draw the diagonals. So let me draw the diagonal here. Good enough. Oh, it's the same color. Okay, so let's do, this is the Y. Okay, so now, let's see if I can draw this. So here are my, it's at 5. 34 is about, so 36 is at 6, so it's just slightly below. Okay, let's see if I can do this. Well, let's attempt. Do not cross. Not too bad. Do not cross the asymptotes, but approach them asymptotically. Not too bad. Okay, not too horribly bad, even though it almost looked like they crossed it. Not horribly, not great, but best I can do. Center vertex, vertex, focus, focus, asymptote, asymptote. Okay. Sketch the graph of this hyperbola. So 9x squared minus 18x minus 25y squared plus 50 y equals 241. And so 9x squared minus 2x minus 25 y squared minus 2y equals 241. Since there's a 1 in front of the x squared, negative 2 divided by 2 is a negative 1. Squared is 1. So let's add 1. Times 9 is 9. Negative 2 squared divided by 2 is a negative 1. Squared is 1. Times negative 25 is negative 25. And so I have here 9 x minus 1 squared minus 25 y minus 1 squared equals 225. Divide both sides of your equation by 225. And so you get x minus 1 squared over 25, y minus 1 squared over 9 equals 1. So A is 5, B is 3, 25 plus 9 is 34. So square root of 34, same as before. The center is at the point 1, 1. The square is positive in front of x. And so the real axis, the focal axis, will be along the x-axis or in the x direction. And so I have here the vertices. I'm going to add and subtract 5. And so 1 minus 5 is a negative 4. 1 plus 5 is 6. Oops. Is 6. The foci are going to be at 1 plus or minus rad 34. The asymptotes will be at y minus the center 1 equaling plus or minus b over a x minus 1. Okay, and so I have the following. So the center is at 1, 1. I will go 5 in the x. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Let's try to draw this. Okay, let's see if I can get closer. That's still hard. Okay, so let's do this. Get the diagonals if I can. Okay. That's your center. And the foci radical 36. Okay, so right, 34 is right there. Okay, so let's see if I can draw this. Eh, oh, let me try to do this again. Okay, so let's see. Not too bad. Better. Okay. Let's see if I can do this. Not too horribly bad. Okay. Even though it looks like I'm going away from it. So let's see if I can approach this asymptote a little bit better. Yeah, a little bit better, I guess. Okay, uh, so much you can do with this tablet. So center, vertex, focus, another one of the foci, and another one of the vertices, and your asymptotes. Okay, so let's do the next problem. Find the equation of hyperbola with foci at plus or minus 13. And so that means that the center will be at the origin. And so, and since the foci along are, along the x-axis, you should have an equation of the so x squared over a squared minus y squared over b squared is 1 a b c. So the foci are plus or minus 13, so c is 13. The vertices plus or minus 12, so a is 12. And again, well, a squared plus b squared equals c squared. A squared plus b squared equals c squared. And so 12 squared plus b squared equals c squared. 144 plus 169 equals 169. Subtract 144 from both sides. So b equals 5. Therefore, the equation of the ellipse is x squared over a squared minus y squared over b squared is equal to 1. And that is the equation of your hyperbola. Hopefully I said hyperbola. I'm not sure. So, but it is a hyperbola. So the equation of your hyperbola. Let's do problem number 31. So I'm intersecting a parabola and a circle. Okay. So I can just use substitution, I guess, in this case. So wherever I see a y squared, I replace y squared by x. Subtract 12 from both sides of your equation. So x squared plus x minus 12 is 0. I can factor x plus 4 x minus 3 is 0. So set each factor to 0 and solve for x. And so let me subtract 4, add 3. And so I have here that x equal negative 4, x equals positive 3, but I have that x is equal to y squared. And so y is equal to plus or minus the square root of negative 4. Well, I don't want complex solutions, so I'll get rid of that. Y squared is equal to 3, since again, x is equal to y squared. And so y is equal to plus or minus the square root of 3. So therefore, I have two solutions. 3 plus or minus rad 3. And so there are 2 points of intersection of this parabola and circle. Solve the following system. Okay, so let's do that. Let me subtract these equations. So I have here, oh, I got to figure out what the heck 33 is. Um, okay, and so so let me do this. So I have here uh, y plus x squared plus 4 is 0. And then let me multiply the first equation by negative 1. So I have a negative y minus 3x minus 2 is 0. So if I add these, I get x squared minus 3x plus 2 is 0. I can factor this. And so I get x is equal to 2. X is equal to 1. And so when, or maybe I'll do this, x equals 2, x equals 1. And so let's figure out what y is equal to. So I have that y plus 3x plus 2 is 0. So y plus 6 plus 2 is 0. Y plus 8 is 0. Subtract 8 from both sides. So y is equal to negative 8. So therefore, one point of intersection is 2, negative 8. Let's try to figure out the other point of intersection. And so y plus 3 times x plus 2 is 0. Y plus 3 plus 2 is 0. Y plus 5 is 0. Subtract 5 from both sides of your equation. So y equals negative 5. So the other point of intersection is 1, negative 5. And so the intersection of this line and parabola are these 2 points. Okay, so 1 second. Let me try to figure out what problem number 33 says. It's going to take me a second here. I'm going to have to figure out what problem 33 is. And so let's see. So I'm going to desperately search and see if I can find this, what it actually is equal to. It'll take a second here as I search everywhere to find an answer to this question. What in the world is 33? Okay, so let's see. Problem number 33. Okay, still looking. See if I can find it. Okay, problem number 33. 30. Oh, this has got a whole bunch of words in it. Okay, so problem number 33. I'm going to have to write something because it's missing the whole question. So it says identify the next term of the given sequence. One, 1/3, 1/9, 1/27, 1/81, dot, dot, dot. Okay, well, notice that we keep multiplying by 1/3. So 3 times 81 is 243. So the answer is 1/243 is the next term in the sequence. Okay, right, the first 6 terms of the sequence. Okay, so let me do that. So let me get some room here to do this. Okay, so f at 1 is -1 to the 1, 4 times 1 over 5 times 1 minus 1. So that's going to be a -4 over 4 is -1. F of 2, -1 squared, 4 times 2 for 5 times 2 minus 1. So that'll be 8 over 9. F of 3 is equal to -1 cube, 4 times 3 over 5 times 3 minus 1. And so that'll be 12 over 14 is -6 over 7. F of 4. I guess I'm going to have to keep going here. And so this is equal to -1 to the 4th, 4 times 4, 5 times 4 minus 1 is a positive 16 over 19. F of 5, -1 to the 5th, 4 times 5, 5 times 5 minus 1 is a negative 20 over 24. I can divide everything by 4, and so -5 over 6. And the last one, f of 6, -1 to the 6, 4 times 6, 5 times 6 minus 1 is equal to, there'll be a positive 24 over 29. Okay, so the first 6 terms of that sequence, I guess I'll just sort of end it here, are going to be -1, 8 over 9, -6 over 7, 16 over 19, -5 over 6, 24 over 29, etc. Okay, so those are the first 6 terms. Problem number 35. So this is there. So problem 25, find the general term of an arithmetic sequence. The general term of arithmetic sequence is the following. So in this case, first term is -5. Common difference is 3. And that's your answer. You can, of course, simplify it, but maybe I'll just leave it in this. Since I have no room, I'll just leave it in that form. Insert 3 arithmetic means between these numbers. And so I have 1, 2, oops, 3 arithmetic means. The general term is the following. And so I have that the last term, so when n is 5, I have 7 is equal to first term a sub 1, 1, plus, well, this is the fifth term, times d. So let's figure out what d is. And so subtract 1 from both sides, so 6 is equal to 4d. Divide both sides of your equation by 4, so d is equal to 6 divided by 4, 3 over 2. And so let's, so I can write my, I can write my 3. So actually, maybe I'll write this. People liked before when I did it, when people did decimals. So I'll do it as decimals. And so the 3 arithmetic means are about 1, 2.5, 3, 4, 5.5, 7. So the 3 arithmetic means are 2.5, 4, and 5.5. Okay. Find the 13th term of this geometric sequence. So in a geometric sequence, a sub n is a1 r to the n minus 1. And so the 13th term is going to be, well, let's see, a sub 1, well, it says the first term, first two terms are 3 and -9, so therefore the first term is 3. And, well, in order to get -9, you have to multiply 3 by -3. So the common ratio is -3. And, well, the 13th minus 1. And so this is just the 13th term is 3 times -3 to the 12. So that's actually going to be a relatively large number. So let me calculate that on my calculator to the 12. So it's a relatively big number. Actually, maybe I'll just leave it as 3 to the 13. So it's a big number. It's 10 to the 13 decimals. So, and I only have 2, 4, 6, 8, 9 decimals. Yeah, so I don't have the exact answer. So I'll just say that it's a big number. Okay, let me do problem number 38. Find the geometric mean. So the geometric mean is just the nth root of the product. Well, in this case, there are only two numbers. So the square root of 8 times 72. 8 times 72 is 576. And so the square root of that is 24. And that's your answer. Okay. Write this with an expanded form. And so I just want to add. So this is equal to 3 times 1 over 1 plus 1 plus 3 times 2, 2 plus 1. So you just first replace n by 1, then n by 2, and keep going until n is equal to 7. And so 2 plus 1, 3 times n over n plus 1, 3 times n over n plus 1, 3 times n for n plus 1, 3 times n over n plus 1, 3 times n over n plus 1. And that's your answer. So that whole big sum here is your answer. Okay. Uh, it's obviously not letting me make a straight line. Let's see if I can do this again. Okay, close enough. Okay, so that is your answer. Okay. Suppose you're offered a job, okay, at $1,500 per month, increase of $13 per month. So initially, you have $1,500 and you have a increase of $13 per month. How much will you make after 12 months? Um, Actually, let me use that notation. Okay. So the formula for the sum for an arithmetic sequence, a series, is the following. An, n over 2 times 2a1 plus n minus 1d. And so, after 12 months, you have 12 over 2, 2 times, well, 1,500, plus 12 minus 1, and the common difference is 13. And so this is equal to 6, 3,000 plus 11 times 13 is equal to, well, let's plug that into our calculator. So it's 3,000 plus 11 times 13, 3143 times 6 is 18,000. Oh, what? Okay, try that. What? Hey, stop. It is 13,000. No, it's not. It's $18,858. And so that is your how much you make in the first year. Okay. Let me do. Oh, which means that, of course, that crashed. Let me do problem number 41. And so I have here, let's add this sum. Well, I know that this is going to equal, this is arithmetic series. So it's n over 2, a1 plus an. And so let's add up the first 18 terms. And so this is going to be 18 over 2. The first term is, well, 3 times 1 plus 2. The last term is 3 times 18 plus 2. And so this sum is equal to 9 times 5 plus, 3 times 18, 54, plus 2 is equal to 61 times 9, 549. And that's your answer. Let's figure out the sum of the first 13 terms. Okay. So this is so this is going to be a geometric series. And so the sum is just going to equal A1 times 1 minus r to the n, 1 minus r. And so this is going to equal, well, to sum the first 13 terms. The first term is 9. The common ratio is 1/3. And so this is equal to, I guess it's multiply by 3 to the 13 and divide by 3 to the 13. So s to the 13 is equal to 9. And so that'll be 3 to the 13 minus 1 over, well, that's going to be 2/3 times, so that's 2 times 3 to the 12. So those are going to cancel. So you're going to get 3 to the 13 minus 1 over 2 times 3 to the 10. 3 squared is 9. And so that's your answer. You can get an approximate answer, but that'll only be an approximate answer. 3 to the 13, 150 minus. So 1,594,322 divided by 2 times 3 to the 10. So this is approximately, well, actually I can write this. So this is equal to, let's do that, 3 to the 13, because I can write that out, minus 1 is 1/5 94322. Oh, divide that by 2. So that's equal to 797,161 over 3 to the 10 is 59049. Okay, so that's okay. So that's what that is, and that's approximately 797,161 divided by 9049 is approximately 13.4, and there's 1, 2, 3, 4, 153. And that's your approximate answer. Let me do problem 43. Find the sum of the first 11 terms. I'm going to, why don't I add a page or something so that I can do that. Let's see if I can add a page here. See if I can insert a new page here. Shoot. Go all the way to the bottom. Okay, let's see if I can insert a new page here. Good. Okay, so see below. Okay, so at least I have some more room here. So 43. It's getting just a little bit too crowded. Find the sum of the first 11 terms. Okay, so in this case, the sum of the first n terms will be this formula, so long as, of course, as r is not equal to 1. So in this case, well, a sub 1, oh, that was an error in the formula. In this case, a sub 1 is 5. The common ratio is 3. And I want to determine the sum of the first 11 terms. I want to figure out that. And so let's plug that in. And so the sum of the first 11 terms is 5 times 3 to the 11 minus 1 over 3 minus 1. And so this is just going to be 3 minus 1 is 2, so 5 over 2 times 3 to the 11 minus 1. And that's your answer, which is approximately, let's plug into our calculator, 3 to the power 11 minus 1 times 5 divided by 2 is, I can actually get a real answer. So it is 442,865. And that is your answer. Okay, so it's not an approximate answer, that's the exact answer. Find the sum of the infinite geometric series. Okay, well, the sum of the infinite geometric series is just a1 over 1 minus r, so long as r is less than 1 in absolute value. Well, the common ratio is a fourth, so it exists. So the first term is 4. Common ratio is 1/4. And so that's your answer. But I can simplify this. Let me multiply and divide by 4. And so this is equal to 16 over 4 minus 1, 3. And so if you add up everything, you get 16 over 3, this infinite series. Let's do problem number 45. So let's do the expansion. So 7 plus 4, 7 plus x to the fourth. This is problem number 45. Okay, so I know that a plus b to the n by the binomial theorem is just the sum. Oh, let's say k equals 0 to n of, oh, well, let's say nk, a to the n minus k, bk. And so 7 plus x to the 4 is equal to, well, let's put that in. So that's going to be 4, 0. So 4 choose 0 of 7 to the 4 minus 0, x to the 0, plus 4 choose 1, 7 to the 4 minus 1, 3, x to the 1, plus 4 choose 2, 7 squared, x to the 2, plus 4 choose 3, 7 to the 4 minus 3 is 1, x to the 3, plus 4 choose 4, 7 to the 0, x to the 4. 4 choose 0 is 1. 7 to the 4th is a big number. So 7 to the power of 4 is 2,401. X to the 0 is just 1. 4 choose 1 is 4. 7 cubed is 343. Plus 4 choose 2 is 6. 7 squared is 49. 4 choose 3 is 4. 7 to the first is 7. 4 choose 4 is 1. 7 to the 0 is 1. X to the 4th. Okay, so this is equal to, let's multiply this out. So this is, and maybe I'll write it in descending order. So it's x to the 4th plus 28x cubed plus 6 times 49, 294 x squared plus 4 times 343, 1372 x plus 2401. And that is your answer. 46. And so 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial, 3 times 2 times 1. 3 factorial, 3 times 2 times 1. So let's do some cancellations. These cancel, and so you get 8 times 7, 56, times 5 times 4, 20. And so you get a 1,120. And that's your answer. Okay. Expand. Oh, so it's doing the same thing that we did here. Matter of fact, with the same, almost the exact same numbers. And so this is going to equal, so using the binomial theorem here, I'm going to do the same expansion. And so n is 4, and so I have 4 choose 0, 5a to the 4 minus 0 is 4, b to the 0, minus 4 choose 1, 5a to the 4 minus 1, 3, b to the first, plus 4 choose 2, 5a squared, b squared, plus 4 choose 3, minus 4 choose 3, 5a to the 4 minus 3, 1, b to the 3, plus 4 choose 4, 5a to the 0, b to the 4. Okay, so this is equal to, let's just see for 1 second if I can, oh, I guess I can't even move that over that much. That's why it was a little scraggly. Let's just see if there's any possibility. I doubt it, but if there's any possibility to make that this last guy look a little nicer. 5a to the 0. Oh boy, it's moving everywhere. Yeah, it's going to be pretty hard. Okay, let's see if I can do this. And then it's b to the 4. Okay, that's a little bit better. Okay, so this is equal to, okay, 1, 5 to the 4, 625. A to the 4 minus 4, 125, plus 6, 25, minus 4, 5a b cubed, plus 1 times 1 times b to the 4. Okay, so let's see if I can do this. So this is equal to 625 a to the 4 minus 500. 4 times 125. 500. A cubed to B plus 6 times 25. 150. A squared B squared minus 4 times 5. 20. AB cubed plus B to the fourth. And that is your answer. And so, let me do problem number 48. Which term of this expansion is constant? So first let me just look at the terms involving x and just look at the exponent. So I know the exponent's got to be 0. And so I have here by the expansion x squared to the power 6 minus k times 1 over x to the k has to be x to the 0. So let me just, don't worry about any of the constants and try to figure out what k is here in the binomial expansion. So if I can figure out what this k is, then I can figure out the constants, but I at least have to know the exponents. Okay, so I have here x to the 12 minus 2k, x to the negative k equals x to the 0. So x to the 12 minus 3k is x to the 0. And this is, since the exponential function is 1 to 1 and I have the same base, then the exponents must be equal. And I'm assuming that this is true for all x. In this case, well, let's just say x is not 0. Add 3k to both sides of your equation. And so divide by 3, so k equals 4. Okay, so good. And so which term is, so for part A, which term is a constant? Well, the fifth term. Since in this case we're actually, if you notice here, we start counting at 0. So if k is 4, then it's the first, second, third, fourth, fifth term. So let's figure out what b is. Actually find the constant term. So let's do that. So this is going to be, the exponent is 6. K is 4. So 6 choose 4. 4x squared to the power 6 minus 4 is 2 times 1 over x, a negative 1 over x to the power 4. 6 choose 4 is 15. Let me do this on my calculator actually. Let's see. 6 choose 4 is 15. Yes, that is correct. 4 squared is 16. X to the fourth. Negative 1 over x to the power 4 is 1 over x to the fourth. So the fourth powers cancel. So I just get 15 times 16. And so that's going to be 240. So my answer is 240. Okay. Good. Let me do problem number 49. Oops. Problem number 49. Oh, a whole bunch of, okay, so So problem number 49 says, let P of n be the statement 41 minus 14 to the n is an integral multiple of 27. Okay, so let's do that. And so I guess I'm going to have to use induction. So I'm going to have to prove this by induction. So let's do the initial case. So let's try to show that this statement is true when n is 1. So 41 to the 1 minus 14 to the 1 is equal to, well, 27. So thus, 41 to the n minus 14n is an integral multiple of 27 when n equals 1. Okay, so let's do the induction case. And so let's suppose that 41 to the k minus 14k is equal to 27a for some integer a. Then I'm going to continue with this for a little while. So then 41 to the k plus 1 minus 14 to the k plus 1 is equal to 41k times 41 minus, well, actually let me rewrite this first before doing the, and so I know that that means that 41k is equal to 14k plus 27a. So therefore 41 to the k plus 1 minus 14 to the k plus 1 is equal to 41 to the k times 14 minus 14 k plus 1. Well, 41k I know is 14k plus 27a. So this is equal to 14k plus 1 plus 27 times 14a minus 14k plus 1. Therefore, the 14k plus 1's cancel. And so I get 27 times 14a. So therefore, I have found, well, 14a is obviously a integer. If a is an integer, then so is 14a. So therefore, so thus, so 41k k plus 1 minus 14k plus 1 is an integral multiple of 27. So therefore, by the principle of mathematical induction, 41 to the n minus 14n is an integral multiple of 27 for all natural numbers n. And so I'm done. Yeah, whatever. Okay. So let me do problem number 50. So I should sort of say that's problem number 49, by the way. Okay, so now let's do problem 50. And so I want to show that this is integral multiple of 2. Okay, so it's going to be exactly the same proof. And so let's do the initial case. And so 1 times 3 times 1 minus 1 is equal to 1 times, well, 3 minus 1 is 2, which is a integral multiple of 2. Therefore, n, 3n minus 1, is an integral multiple of 2 when n is equal to 1. So I've shown the initial case. Let's do the induction case. So I have, so let's suppose, and so let's suppose k, 3k minus 1 is equal to 3a for some integer a. 2. 2. 2. For some, it's supposed to be integral multiple 2. Okay, so for some integer a. Okay, so let's do that. Okay, so k plus 1 times 3k plus 1 minus 1. So let's look. So this is equal to k plus 1 times 3k plus 3 minus 1 is equal to k plus 1, 3k plus 2. And so I have here, oops, so k, 3k. Oh, and let's see. I want to write this actually, if I can do the minus 1 plus 3 is equal to, well, this will be k, 3k minus 1 plus, let me bring it to the other side, I guess, equals k, 3k minus 1 plus 3k plus 3k minus 1 plus 3. Okay, so just multiplying this out, I get that. So this is equal to 2a plus 6k plus 2, which is equal to 2 times a plus 3k plus 1. And so I've shown almost no room, but let's see. Okay, so therefore, well, k plus 1 times 3k plus 1 minus 1 is an integral multiple. Oh, maybe I'll just let that go. So is an integral multiple of 2, which implies, by the principle of mathematical induction, that, well, what we wanted to show, n times 3n minus 1 is an integral multiple of 2 for every natural number n. So QED. Okay, and that's it. Okay, so let me just select page, get rid of that page. Okay, good. And so that finishes off problem number 50. So we're done.